All right, this video is going to be on solving absolute value equations and absolute values mixed with an inequality. So let's start with just solving like a basic absolute value. So remember, the definition of an absolute value is the distance a number is from zero. So you have to think about the distance it is. You have to think about it being like a positive number because it's a distance. So there are problems that are going to create things that are not possible. And I don't know that I want to start with I'm going to start with this. Okay, let's look at the first example that I have here is 3x minus 4 absolute value equals 11. So an absolute value could never equal a negative. So if this was a negative 11, you couldn't do it. So we can do this one, and we have two solutions, one that would make a negative under here and one that would make a positive. So the way that we set this up and solve is we think, well, write down exactly what I see. So 3x minus 4 equals 11. And then write down 3x minus 4 equals negative 11. Because if this, under the absolute value, equaled negative 11, you would then take the absolute value of it, making it positive. So these would form our two solutions. So let's solve this one. First, we'd add the 4 to both sides. And then I'd get 3x equals 15. Okay, then divide by 3, and x is going to be 5. Okay, so there's our one solution is 5. The other solution, we'll do the same thing, add 4, and I'll get 3x equals negative 11 plus 4 is going to give us negative 7. Divide by 3, and I'm going to get a fraction. That cancels here. And just leave it negative 7/3. You don't need to say, well, it goes in there 2 1/3 time. Just leave it there. Especially if you're using my math lab, it makes you put it in as 7/3. It doesn't like it to be converted. Okay, so these are two answers. And sometimes they make you put them in a set. They put the bracket in. You just say 5 and negative 7/3. It's the set of answers because there's more than one, but no weird notations for this one. All right, let's look at one that has a little more steps than that. Let's go. What if I would have had 2, 3, we'll start with this. So what if we had something like this? So here's the absolute value in here, but there's numbers by it. It's not by itself or isolated like the problem before. So what you're going to do is you're going to isolate that first. So we'd add the 3 over to isolate that. So add the 3, and I would have then 2 absolute value 3x equals 10. Then it's still almost by itself, but then you have to divide by that 2 on both sides to get it completely by itself. So then you're going to have the absolute value of 3x is equal to 5. And now that I have the absolute value by itself, I can then find my two solutions. So write down exactly what you see, and then 3x equals the opposite, negative 5. Divide by 3, we're going to get some fractions because I made this up. So we got x is 5/3 and x equals negative 5/3. All right, and those are our two solutions for that one. Okay, so that you could end up having to do a couple steps to isolate your absolute value. So for some of you, you would be done here that are in my high school classes. You wouldn't have to keep watching this video because we don't add the inequalities yet into the absolute value. And if we did, you'd still be able to do it. It's not that challenging. So let's look at what happens with the absolute value with a greater than or less than symbol. So first of all, think about it if it doesn't really matter what we have within the absolute value. If it's a greater than, then we're going to solve it and it consists of two separate intervals, or it's usually an or type situation. So let's see. So it would end up being, I was trying to read this notes, x plus 2 is greater than k, so exactly what I see, and then you would end up switching both of them, the inequality and the negative. So you have to switch both signs on this one, and it would be this one or this one. And I will give you an example of that. And the next one we might get is, what if it's less than k? So if it's less than k, then it's going to be a compound inequality or an and there's two ways you can do this one. The book kind of shows it a little more complicated. You still do it exactly like you see. You're less than this, and you're greater than, or and you switch both, the negative k, greater than the negative k. Remember, KAB will represent just numbers. This is an and situation, this one and this one. Another way to write this is you would have negative k, and then you have the ax plus b is less than. Okay, so this is a compound inequality. So you're saying this is greater than negative k. That's exactly what we say here. And it's less than k. Exactly what we say here. We read it from the middle, greater than. They show this on a lot of the examples. It really, you don't have to write them together. So just know if you start with a less than, you're going to have an and situation. If you start with a greater than, you have an or situation. And again, you don't even have to have that memorized as much unless it asks that specifically. Now I can't remember, but because once you solve it, you'll know if it's an and or an or. But let's look at some examples of this one. So let's see, I'll just start over with one for my examples on this one. So if I have 3x minus 4, absolute value is less than or equal to 11. So if I have something like this, it's less than or equal to 11. We'd set up our two inequalities. It starts with a less than, right? So it's going to be an and situation. And we're going to solve it as 3x minus 4 is less than or equal to 11, or 3x minus 4 is greater than or equal to negative 11. Okay, so add the 4, and I get 3x is less than or equal to 15. Divide by the 3, and I get x is less than or equal to 5. Same process over here. Add the 4. So 3x is greater than or equal to negative 15. Or no, not the other way, 7. I don't know why I couldn't think of that all of a sudden. 11 minus 4. Anyway, so negative 7, and then divide by 3, and x is going to be greater than or equal negative 7/3. And I think this is the same example I just did, and I still am struggling. All right, so then from here, you can see x is less than 5, but greater than negative 7/3. So on a number line, we would have the square bracket, and you're less than 5. And remember, 3 goes into 7, 2 1/3. So it'd be about, here's negative 2, here's negative 3, about a third past that. And you're saying you're greater than. So you can see the and situation because they go at each other. And that's usually our and situation. So even if you don't quite get when to combine them and make them compound, you can still solve them and find it. But if you start with less than, it's an and, okay? And so our solution is actually going to go from negative 7/3 to 5, and you include both endpoints. Okay, let's look at if it would have gone the other way. Okay, let's look at this problem. What if I have x plus 2 minus 3 is greater than 2? This one here. First of all, we can't decide if it's greater than or less than until we have the absolute value by itself. So we're going to do that by adding the 3 to both sides. That's going to give me x plus 2 over here is greater than 5. Now that it's by itself and we have the greater than 5, we can set up and look. If it's greater, then we're going to say it's an OR situation. So x plus 2 is greater than 5, and x plus 2 is less than a negative 5. Because you start with greater than it, and then you're going to be less than, you're going to go the like out. Each ones are going to point out, so they either go in or out typically. So then we minus the 2 over, and x is greater than 3. Minus the 2 over, and x is less than negative 7. So if we thought about, I'm running out of paper here, but that's all right, I can still fit it on here. Here's 0, 1, 2, 3. Here's 3. If you're greater than 3, and it's a round bracket, right, because you're not equal. 1, 2, 3, 4, 5, 6, 7. If negative 7's way out here and you're less than, you're going this way. So you can kind of see the OR situation is going out. And to write that in interval notation, you might be able to hear my kid in the background. So you would go from negative infinity to negative 7 and then stop. And you would union that with 3 to infinity. So you include both sections. 1, 2, so you have to do 2 interval notations with that union symbol. So, hang on just a second. So if you have a greater than, or if you have a less than, an and. Making a video, hang on. Yeah, I'm a real mom talking. He thinks I'm a pretend mom, I think. All right, anyway, that's pretty much all that you're going to go over in this section. I was trying to think if there was any other ones. They have a couple that that don't work. Like if I had that this was greater or less than, goodness, I can't even think. If I had it equal to a negative, it can't be possible, right? Also, if I included like if it's less than 0, right? So if I had the absolute value by itself, like at this step, if I said that was less than 0, you couldn't have a solution, right? If you have to be careful of, it can't ever equal a negative. So there are some tricky ones that you could be thrown at you. Otherwise, that's the gist of how you do those ones.